3-4 years ago, everybody treated all carbon offsets the same. They didn't realize there was nuance between them. Now that's changed. Everybody needs to now pay attention to the same thing in terms of renewable energy. If you do not pay attention to the fact that there is a lot of variability in a lot of this stuff, it's all going to get tarnished with the same brush in the future, and any renewable energy claim is not going to be trusted.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to the Week in Green Software, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. This is our news roundup show in the Green Software Foundation podcast. So we aren't doing a domain expert deep dive where we go into a deep, narrow subject, but rather we're taking a more broader view. So we'll try to add some context and commentary to the stories that have been shared with us that we discuss with our guests. With me today is my friend, colleague, and mushroom enthusiast, Asim Hussain of the Green Software Foundation. Asim, it's really good to see you again. How are your holidays?
Yeah, it's been quite a long time off, and just gently dipping my toes back into the swing of things. Glad to be on the show. It's a nice, gentle introduction back into the world of green software. So glad to be here again, Chris. Asim Hussain, I'm the Executive Director of the Green Software Foundation. And yeah, I spend my day probably similar to you, thinking about how to advocate for green software. What do we need? What are the questions that need to be answered? And what are the levers that we need to pull to get action taken in this space?
Reduce the environmental impact of digital services.
That's right.
Yeah. Okay, cool. Thanks. I should introduce myself as well. Hello, folks. My name is Chris Adams. I am the Executive Director of the Green Web Foundation. That's a different organization. We are a Dutch nonprofit focused around reaching a fossil-free internet by 2030. And we do that using open as a lever. So we do loads of stuff with open source, open culture, and things like that. As a quick reminder, we're going to share all the stories that we have and any projects or things that come up. We'll add to the show notes. So if you want to continue your quest to learn more about green software and how to reduce the environmental impacts of digital services yourself, just look at podcast.greensoftware.foundation to see this. If you're looking in Spotify or some of the other podcast tools, you might not be able to see the links. So please do go to the website to see the show notes, and you will be rewarded with diligently prepared links and helpful notes and a transcript as well. All right, then. So I guess, Asim, I've introduced our news roundup format. We kind of know what we're going to do. We've done this a few times. I assume you're sitting comfortably. Shall we begin?
Well, yeah. Yes. Yeah, let's go for it.
All right. Okay. So the first story I see here is actually a post from Sasha Lucioni, Bruna Tevelin, and Margaret Mitchell, Hugging Face, the environmental impacts of AI, a primer. So this is one thing we had shared. And Asim, I'm going to ask you, you've had a chance to look at this. What made you think this was actually worth discussing? And what would you draw people's attention to if they had heard about this? And how would you persuade people that this is worth a read, for example?
Well, I suppose if you're new to the space, and I think there's a lot of people out there for whom are kind of surprised to find out that AI has an environmental impact. So this is, a lot of this stuff. Obviously, we've been talking about different components of it over the last couple of years. But I think it's a great summary of the different components of what makes environmental impacts of software. It's also got information there about what are some of the legislation coming down the pipeline, what are some of the actions that you can do, and some things there. So I think it's a really good kind of primer for people. I think it's the title. Is the title primer? It isn't.
Yes, it's
a
primer.
So it does what it says on the tin, and I think it's probably could do as a really great introductory piece of information. It's got some great links there as well.
Yeah, the thing that it might be worth just focusing on briefly, or one thing that leapt out at me when I looked at this, is that it talks about the direct environmental impacts of AI specifically. So rather than talking about AI for good, or isn't it great that you can use AI to, say, make it easier to deploy renewable energy or do this or do that, right? They're talking about, no, there's an environmental impact that you still need to address regardless of whether you use something for good or for bad. And it seems to be focusing primarily on that kind of stuff. So as a responsible engineer, these are the things to think about. These are the kind of what you call them impact criteria, like there's carbon emissions, there's water, there's other things like that. And generally this is from one of the kind of most trusted hands-on group who are like at the coalface for all this stuff. I mean, maybe is coalface the correct term?
Yeah, I always use that term as well.
Yeah.
And then I'm like, actually, that's terrible.
Maybe if you're in US AWS East, it's coalface, and then if it's on AWS West, it's hydroface. I don't know.
So I use coalface, and then then I sometimes use front lines, and I'm like, actually, that's not a good term as well. We need a term which doesn't have a war metaphor or
industrial revolution
metaphor. But anyway, it's at the cutting edge.
Yes,
cutting edge. There you go.
Okay, that'll do for me. All right then. Okay, that's the first thing. I think on a follow-on from this, when I was reading this, I quite liked that it actually touched on some of the regulatory drivers that you have, because it's very common for people to talk about the AI Act, because that's probably the first piece of legislation, but it also calls out stuff taking place in Spain and taking place in the US. And it shows that there's a kind of growing, I guess, regulatory trend to basically say, well, if you're going to have this piece of technology in society, then we need to have a data-informed discussion about what impacts it might actually have. So we can talk about, okay, where is it responsible to deploy this? But also just like, okay, how do we actually mitigate this? Because, I don't know, it seems like cars are useful. And the fact that cars are useful doesn't mean that we don't talk about seatbelts, right? You still have to talk about them being safer, regardless of how useful they are, basically. So it's really nice to have a trusted organization sharing some information like this in a relatively roundabout, in my view, quite concise fashion. But if you look at the set of footnotes, wow, there's so much stuff that you can dive into if you wanted to kind of go down that rabbit hole, basically.
Yeah, it's a very well researched, kind of almost a state-of-the-art paper. And I also say, like, I think it's also good to know, because people don't, yes, there's regulation coming down the pipeline, and some of that stuff is more mature than other regulation. But I think when you're working inside, large enterprise organizations, this is the kind of stuff that gets people to pay attention. You can be talking for ages about, hey, look, there's the carbon impact. It's having we should be looking at our AI usage. And sometimes that can land and sometimes that can't. But a regulation or the threat of a future regulation is something that I've seen personally open a lot of doors. It doesn't kind of complete the internal sale of we need to invest in mitigating the impacts of our AI use, but it's certainly, I've seen it kind of open up a lot more doors, because regulation is something that a lot of organizations pay significant attention to, and it's also something that they will invest time before the regulation comes out to look at it and to put effort into it. So I look at that and it's great to see, because those regulations that I wasn't aware of. So I'll be obviously using this it's a great primer for me as well. But this is a really good way of capturing people's attention. So then you can have that more refined conversation about, well, how are you using your AI? Let's have a conversation about it. How is future regulation going to affect you? So it's a really good way of opening that door. And if you're inside an organization and you are a little bit concerned about the consumption of AI that you're having, I think for me personally, like pointing out the regulation that's coming down the pipeline does open a lot of doors and enable some conversations with leaders.
This actually might be a kind of somewhat appropriate time to mention some of the kind of policy stuff we're doing, because so in addition to doing the podcast here, I help co-chair the policy working group, and we're likely to be getting a policy radar out to see precisely this kind of stuff coming up. Because, if you didn't know, today's the 6th of September, and you've seen this whole energy efficiency directive thing in Europe, right? So in 9 days' time, every data center that uses more than 500 kilowatts of power draw has to start reporting and posting in public or their absolute energy use, absolute water use, the amount of energy coming from renewable energy, how much it comes from the kind of credits that you might buy, which are unbundled, how much is coming from a power purchase agreement, so the kind of green energy that you've purchased directly. There's all this new stuff. There are some caveats around this. So not every single organization will probably publish, but we basically have a regulation that's saying, look, this has to happen now in 9 days at the time of this recording. So when this goes out, it probably will have already happened. And like this gives you an idea that if you didn't know this is happening, then you probably do need to know this, because this is written into the law in lots and lots of countries now. Well, all across Europe, for example. And I suspect this is the kind of thing we might see in other parts of the world, because when you look at the figures and look at the data that people are currently basing policy on, it's really hard to figure out what the environmental impact of, say, data centers might be, or what the growth is going to be. And if you want to plan for a grid or plan for hitting some climate targets, this is the kind of stuff you need to actually be knowing about.
But it's also useful because we've been having these conversations for a while about, I think we've spoken on the podcast a couple of times in the past. When we were developing the size specification, it came up a lot. Like, do you include the data? How much of data center do you include? But the biggest problem is that you don't know. So if you decided to put into the specification, you've got to include certain, the concrete or whatever it is that goes into a data center. If that data is not public, then what's the point of putting it into specification? That's why these regulations, that specific regulation, is so interesting. I'm interested to see what actually happens in 9 days' time and the quality of data that comes out. The conversations I've had in the past, because when this first started being discussed, I was chatting to a lot of, not data center operators, but people that worked with data center operators. And obviously it kicked up a storm and everybody's like, well, I need this data. How do I get this data? What is the minimum level of information I can provide to meet? And that's where it gets really interesting for me. What is the minimum level of information I need to provide to meet the regulation? And I think in 9 days' time, we're going to find out what is the minimum level of information that people have figured out that they can provide.
They can get away with.
That they can get away with. Because when I had that conversation, I don't know where it landed now, to be honest with you, but they were like, is it at the building level? Is it at the rack level? And it was like, it's at the building level is where it was left at. So I think the more and more this regulation comes along and it kind of surfaces this data to us, then we can then use that data to make more informed choices. Hopefully not from a consumer level. I think it should be not from an end user level, but from the people who use data centers and make different choices.
I think you're right. Yeah. Okay, well, we'll share a couple of links to this, because this is something we've discussed in a few places. There's one or two working groups where this has come up in particular, because there's also on the just before we move on from this, there's a current kind of, in my view, an interesting discussion going on about, okay, with this in Europe at least, with this AI Act, yes, it says that you need to disclose the training data, the energy used for training a model, right? But it's not totally clear if you need to also track the inference, right? So if you think about the training part, and I've shared a link to a blog post where I basically highlighted the bits of the law that make me think that you might need to track inference, or at least disclose some information about likely inference. Because you can think of like the training part as like the energy gone into making a car, and then the inference figures as a bit like the car's mile per gallon for that model, for example. And it's not totally clear yet, and we've seen the law passed, and we'll figure out. Yeah,
because I'll be honest with you, I assumed it included inference. The only time I didn't was when I just read your article, and I was like, oh, hang on. That's where these things get very interesting to me. I mean, when I was working in enterprise organizations, and one of the things that was always interesting to me was whenever I asked questions or got meetings together, let's talk about, we've got some questions about how do we calculate this figure to meet with this specification? And there's almost always, legal got involved and lawyers got involved. And I was always I'm like, I don't need to speak to a lawyer. I need to speak to an engineer. Why am I speaking to a lawyer? Because it's all about, let me read this text. What can we interpret from this text? What do we need to give? So I assume just because we know inference is where most of the emissions are these days, I just assumed it was that. But you've now actually read the text and gone, the text is interpretable.
Well, yeah, because you think about when this initiative was written ages ago, a few years ago, it's gone through this massive kind of gestation process, right? And a couple of years ago, when we hadn't really got to this point where AI is being deployed in the same way, what was it, November 2023, that was 100 million users. OpenAI had gone from 0 to 100 million users in 5 months. And maybe last week, we should share a link to Simon Willison's blog post, because he wrote about this quite eloquently. He's like, well, OpenAI have just mentioned that they're now at 200 million weekly users. So that's doubled in a single year. So we've gone so inference is now a significant part of the story in a way that it wasn't previously, basically. So it may be that the law, when it was written 2 years ago and began that process through it, it might not have been such a concern. And this is the thing that this is why it seems a bit unclear. And I think we'll probably end up with a test case that will set a precedent for people to figure out what they should be sharing or what you might need to share if you're building new foundational models in future.
I mean, I can tell you that pre-Chat GPT kind of announcing, it was very well known that inference was significant, as in way more than training for any, like, I can't reveal too much, but, you know, it was known very much that was the case. And a lot of effort had been put into mitigating, not from a carbon emissions perspective, just from a cost and energy, just all of that stuff. So it's kind of known. It might not have been in the zeitgeist. It might not have been in the kind of the public discourse, because it's so much easier to talk about, you know, this big training run. And maybe there's just more public data about that, because inference, in a way, if you think about it, is going to be pretty private, because that's inference is basically telling everybody the business end of your, you know, where you're making money from. And they'll probably keep that pretty private. So yeah, maybe it just wasn't well known, but it was true and well known, I think, to anybody in the kind of the AI space, that inference was a pretty big deal prior to this. But yeah, what makes sense. Yeah, these acts take a long time. So yeah, a couple of years ago, all we were talking about was training. It was a good headline to discuss. Yeah,
useful insight from the inside track, Asim. All right, so. There's one thing you mentioned, actually, just on the subject of inference. There is this, in my view, really interesting project right now, Energy Star AI, which is a project which is, you see a few names associated with, so Sasha Lucioni, Sarah Hooker, Regis Pirard, Emma Struble, Yassine Shanita, I think, Carol Jean Wu, and one of our own at the Green Software Foundation, Boris Gamazaychikov. He's at Salesforce, and he's been one of the people who's writing publicly about a bunch of this stuff, and also about like the small models as well as large models. And I was really pleased to see his name, actually. So hi, Boris. If you're listening to this is a really good story to look at, because it's essentially is talking about inference and saying, well, let's find ways to make this visible for people, you know, 2 years later now, basically, and say, well, let's see if we can find ways to introduce some of the incentives to go for more efficient inference, the same way we've done with Energy Star in other kind of industries, for example.
There's really interesting, I'll try and get her on the podcast, actually. She's from IBM. Her name's slipping me, so I'm not as good as names with you. You can just rattle them off, but I'll make sure to put it in. Because yeah, there's Energy Star for AI, but there's conversations inside the foundation as well now, kind of looking at Psi and how do you apply Psi to AI, and kind of there's a lot of overlap with a lot of this work as well. But what's interesting is there's this real question about what to do when it comes to inference and training. Like, if you were to report that, how do you report that for a model? And the point that was raised, and I thought it was so, because I'd never thought of it before, which is, if you've got a foundational model, you've done the training, you've done a big training run for a foundational model, and you're now then running inference on that. When you report, let's say, I don't know how, I think Energy Star is just going to be like a good, bad kind of label, whereas size more like a score, like a carbon per prompt or something like that. How do you apportion the training into the, do you include the training every time you call it? Because if you do, there's a really interesting thing that happens, which is these foundational models, like if you're using an open source model and that costs 10,000 to run, do you include that in your AI solution and then just say like, oh, I'm 3 grams per prompt? Then somebody else uses that foundational model. Do you then divide that by 2 and say, well, now you take half and you take half? Kind of question, yeah. Right? And then like, if that is how the measurement eventually lands, then if you're an unscrupulous organization, all that you would do is try and get as many people to use this foundational model as possible to then dilute your numbers. And so I think one of my little bugbears, and it comes up quite often, is the assumption that something that works in the physical realm will work in the digital realm. And one of the things I try and educate people as much as possible is that stop trying to take something that has worked in the physical realm and apply it to digital, because there's so many ways it just doesn't work. If you're thinking about training like a Scope 3 embodied carbon physical device thing, you can't divide a chip in 2 and I give you half and it's like that chip's yours. But you can do that in the digital realm. So there's this whole supply chain accounting aspects of digital emissions, which it just needs to be thought of differently in the world that we're in. And if you don't think about it differently, you can then have, I call them unintended, we used to call them gaming, like when people were developing the Psi, like one of the conversations we'd have on the calls is, how is somebody going to game? How is somebody going to take the Psi?
Software carbon intensity.
Software carbon intensity, yeah.
Okay.
how is somebody going to game the size? That's kind of a lot of the conversations we had at the start, because obviously everybody was like, we want to make sure if we develop a standard, people aren't going to then abuse it, and therefore the standard has no respect in the world. And so like a lot of how I kind of work with the standards projects here is I'm a bit of an annoying devil's advocate. I love it actually, because I kind of walk in and go, here are 10 ways I can hack this standard to present a better score without actually doing anything. And so I think that's some of the things we need to think of as we think of Sci for AI, as you think of Energy Star, as you think of these other things is, yes, there's this happy path that if everybody's a good actor, it will work and it will give you the right signal. But we need to think about the non-happy path where people might not even necessarily be bad actors. It's just death by 1,000 cuts. You're working in an organization, you've got a deadline, you've got a bonus you have to meet. There's a customer that you're going to have to get or you lose your business. And so you'll just death by 1,000 cuts. So yeah, we have to be very careful as we explore like Sci for AI and Energy Star and anything really in this space, which is talking about measuring emissions. Because if you don't think through those unintended consequences, that's a problem. And that's one of the ones I have is, if you're including training, how do you apportion that? You might not actually want to include training. You might actually want a separate, you might actually only want to measure the inference because that gives a truer figure. But yeah.
So to cap this off, as we move to the next story, I'm going to share two links which might be useful for this. So the first is the link to the Meta Llama 3.1b, their model card. Where they literally say, the methodology used to determine energy use and green it can be found here. They've linked to it, and they said since Meta is openly releasing these models, training energy use and greenhouse gas emissions will not be incurred by this. So they're basically saying you don't need to count that part. That gives an example. We'll share a link to that. The other thing we'll share a link to for the show notes is actually the Asim for the software.
Is this me?
Carbon. Yeah, this is your.
Yeah, this is my unintended.
This is a good example because this is where you've basically said, this is me like red teaming this approach. Yeah. And these are the ways I can basically, in bad faith, try and engage with this example. And this would probably be useful for people who are looking at this to get an idea of like how some of these standards or some of these conventions are being developed. All right. Should we move to the next story? Because it kind of does relate a little bit to basically tweaking numbers to present a view of the world, basically. So this story is now how tech companies are obscuring AI's real carbon footprint. This is a story from Bloomberg, I believe. Asim, do you want to introduce this one?
So I thought the reason this kind of popped up on my radar was I forgot what I posted on LinkedIn, but I started posting a bunch of information on LinkedIn about the use of RECs and the effectively like kind of renewable claims that organization makes, and how it's in a really frustrating way. It actually puts us and what we're doing in kind of competition with this very important energy transition. Because the argument I'm making is, look, you can either do two things. And then we'll talk about AI. Let's keep it to AI. You can either make your AI model more efficient so it consumes less energy, or you can do absolutely nothing and just buy offsets, energy offsets, RECs, whatever you want to call them, to mitigate theoretically your energy offsets, your energy consumption. And that's kind of like being this, are we friends? Are we not friends? How do we want to support the energy transition, but at the same time, we really want to advocate for more energy efficiency. So, and I think one of the things we've spoken about is that there's, when you do make these renewable energy claims, one of the things that you do with all types of offsets to kind of avoid a greenwashing claim, you have to have that additionality component to your offset, which for the audience means that, if I'm saying this thing is offsetting your emissions, what is it, a litmus test to say that is a true statement? And is basically, are you actually adding? So for a renewable energy credit, it's like, if you weren't to buy this renewable energy, would that thing have happened?
So you're talking about the counterfactual here, right? You're trying to compare something against. You see a load of this in the hydrogen circle, in the world of hydrogen, because just like data centers, hydrogen electrolysis, like the electrolyzers use loads and loads of energy, right? And one way that you can do that is just by plugging them into the grid, right? And there's various people doing various things to say, well, I'm just going to buy a bunch of, say, renewable energy credits, right? And that's going to make that count as green. And that's in some ways that's kind of somewhat problematic, because essentially
you're burning coal to make hydrogen.
Yeah, that's not exactly what. you're in many cases you're burning coal to make hydrogen, so the actual it's a net loss in climate terms, but also there's been a big fight in the kind of hydrogen world of to have like this notion of three pillars, where you basically, if you're going to count something as green hydrogen, then you need to be talking about new infrastructure being added to the grid to provide net new supply. You can't just take from the existing stock of green supply and then count that as green. And this is one of the things that we've seen. Like Amazon made the news, I think a while, because they basically acquired a data center from a company called Talon, I believe, where they're right next to a nuclear power station, right? So there are some people saying, oh, this is great. Isn't it good that Amazon's using a bunch of clean power? But then you've got to think about, well, okay, who was that clean power going to before? Was it going to the grid? Like there's a whole discussion there about this. And
displacement.
Yeah, so there's a whole set of things to be talking about. And this is why this is such a kind of fraught area, basically.
But I think the way to bring it back to the thing that people understand is when we talk about carbon offsets. I think now it's more understood that it's kind of like that you have carbon removal offsets. So if you can plant a tree, right? And then you planted the tree, that tree will grow. And there's issues there. That tree will grow and it'll suck carbon from the atmosphere. And you can say that's a carbon credit at planting a tree. Or there's carbon avoidance offsets. And there's many variants. And there's actually very good variants of carbon avoidance offsets. But there is a variant of a carbon avoidance offset where I've got a tree and you pay me not to cut it down. And so where is the additionality? If I'm actually planting a tree, it's happening. I'm planting a tree. I'm adding additional kind of capacity in carbon removal. And in the renewable energy markets is exactly the same. You can have renewable energy, which if you buy means a renewable power plant is going to get built. And you can have renewable energy, which is just kind of sold. And if you buy it or you don't buy it, there's no change. Nothing's going to happen. There's no more new renewable plants going to get built. Only one of them has that additionality component. And so therefore, only one of them should really be used in any kind of renewable energy claims, but both of them are allowed in terms of renewable energy claims. So in terms of what this article is talking about, when they're saying tech companies are obscuring AI's real carbon footprint, they're actually talking about companies using what's called those unbundled RECs, which is those RECs which do not have that additionality component. And then buying them and then saying, well, that's mitigating my environmental impact. And what the article is talking about is really you should be looking at higher quality renewable energy credits, ones with more additionality components to it. And I think that's really interesting. There's actually also Oliver Corradi from, don't know if I'm pronouncing his second name correct. Electricity Maps. Yeah, when I was talking about, he shared a really interesting article he'd written a year ago, which I thought was interesting as well. I'll share that here if you've got it. Yeah. He's actually advocating for like a more nuanced approach to looking at renewable energy, in that, there's additionality, then there's additionality, then there's additionality. There's like different levels of additionality. There's like, this definitely 100% would never have been built unless you bought this renewable energy credit. And there's other ones like, we may not have been able to build it, but we had some funding from here and there. So there's kind of different levels of additionality here as well, which I thought was really interesting also. I'd never thought of additionality more than just a binary yes, no. And he was saying there's actually more of a score for a renewable energy credit.
Yeah, there's totally a continuum there. So the thing I might share for people who are looking for something actionable to work with here is basically the numbers that you often see reported by technology firms. There's all this nuance hidden behind it. And there's one project called the Real-Time Cloud project inside the Green Software Foundation, which essentially is a data set of the largest three providers. So that's Amazon, Google, and Microsoft. And they've got the figures shown in both the kind of location-based figure, which is the closest thing you might think to like the physical location, the physical impact on the ground. They also talk about some of the market-based figures, which is what lots of firms like to use, like market-based on an annual basis. But they also provide a few other details and a few other ways of talking about it, because some firms are now talking about hourly, basically hourly green energy versus annual green energy, with the idea being that it's a way to try and avoid making claims about saying, I'm running a data center at night with certificates coming from a solar farm. This is inherently a little bit silly. They address that stuff. So there's now, I think it's in the final stage of what's referred to as consistency review, where every member in the GSF is able to just say, hey, I object to this, or I'm not sure about this. And then, there'll be an open data set for every single region from the three largest providers, which make up more than 2/3 of the entire cloud market. So you have some meaningful numbers that have come from the actual big providers themselves that you can actually, that we can work with.
And I think basically I think the point I'm generally raising out there with another kind of one of the reasons this article was very interesting to me, and especially the work the real-time cloud is actually interesting. 3-4 years ago, everybody treated all carbon offsets the same. They didn't realize there was nuance between them. Now that's changed. Everybody needs to now pay attention to the same thing in terms of renewable energy. If you do not pay attention to the fact that there is a lot of variability in a lot of this stuff, it's all going to get tarnished with the same brush in the future, and any renewable energy claim is not going to be trusted. So I'm kind of guiding and advising organizations to pay very close attention to kind of the type of renewable energy that you're buying, and be aware that because of podcasts like ourselves, there's generally, it's a Bloomberg article talking about this right now. It is now becoming very aware in the minds of a lot of people who care about this space, who listen to our podcast, who are paying attention, that there is nuance here, they're paying attention. And so as an organization, you need to pay attention to this as well.
Cool. Asim, I'm just going to add this one thing because I realized I should have mentioned this. So I work in an organization where we do track some of this stuff. We track the transition of the internet away from fossil fuels to greener energy. And I've shared a link for the show notes because we're basically reviewing our own evidence that we accept for green hosting. And we've linked to a couple of papers and specific reports which dive into this a bit more, which have kind of also prompted us to start looking at this. So organizations like the Science Based Targets Initiative, we mentioned there. We talk about some of the other things that some of the nuances around REX. And this will be something we'll be doing. So we're going to be essentially figuring out how to do this ourselves in the open over the next few months. So I guess it applies to small firms as well as large firms.
Yeah, yes, absolutely.
All right, should we move to the next story? So this is a story. Researchers analysed 1,500 climate policies to find what works. And these are the lessons for Australia. I think this is the link you shared with me, Asim.
Yeah.
There's a very kind of Australian-centric kind of point of view, which as someone born in a small mining town in Australia called Prospect, because what else would you name a mining town other than Prospect?
Sorry,
it's full
you?
Of yeah.
I didn't know you were born in Australia.
Yeah. Oh, yeah. Born in Australia. Small mining town. Yeah, I was literally born in a mining town called Prospect. And it's near One Tree Hill. Can you guess how many trees are on that hill? And it's next to Dry Creek. Can you guess how the conditions of that river? Yeah.
Australians are very...
descriptive rather than creative is the term I've heard people in Germany who do similar things talk about that actually. Okay, so you shared this story. Maybe you can introduce this one here because I think it's quite relevant in this discussion, what we were just talking about in the previous two stories, actually.
So I think it was just really interesting. It was an analysis of like 1,500 climate policies and just really looking at what worked and what didn't work. And I thought it was interesting because we've spoken a lot about things like carbon levies and things like that on this podcast. But what I found interesting about this article was they, again, brought nuance to the discussion and saying, actually, there's different policies seem to work for different types of organizations. And also combinations of policies seem to work better than individual policies. So a couple of interesting ones. So one of the highlights I got, so some of in developed economies, some of the most successful cases were the results of 2 or more policies working together. So that could be like a ban or something, as well as like a carbon tax, kind of pulling those things together. Oh, so for instance, like a great example they had here was like, for example, a fuel efficiency mandate for vehicles combined with subsidies for developing like charging stations and things like that. So then you've kind of got the pressure on both sides. And another thing that was really interesting was, because we spoke about kind of carbon levies and pricing, was particularly effective policy in sectors dominated by profit-orientated companies such as electricity and industry. So I just think it was really interesting to kind of think through it from that perspective.
So there's a really nice example. There's a few really good concrete examples of this to make this like something you can like get your hands around. So in America, right, we've seen the Inflation Reduction Act. So that in many ways, it's all carrot, no stick. So the idea is that there's massive amounts of subsidies for building out for EVs or building out new kind of battery gigafactories or all this stuff like that, or things which essentially make deployment of renewables much, much more profitable than they otherwise would be, because they're going to, because you have all these kind of subsidies saying, well, we're going to give you a production tax levy. So for every unit of energy you produce, you'll be able to get, you'll get a credit that you can actually apply. So your project over the entire length of it will end up being slightly more profitable. There's stuff like that you see, which is coming from one end. But we've also seen in America, the EPA, the Environmental Protection Agency, they've now come in with a stick, or they're coming in with a stick now to basically say, well, we're going to have to regulate carbon emissions. And this now means that it's going to be all new kind of coal-fired power stations or gas-fired power stations. There'll be all these restrictions on how you can use them. And this is the reason I raise this in America specifically is we were talking a little bit about AI before, right? Now, these regulations, I don't think that many technologists are aware of right now. They basically say, if you're going to run a gas-fired power station, you need to fit loads of carbon capture and storage onto it, which is, broadly speaking, if it does work, it's not something that's really used in large amounts right now.
Yeah.
And what you currently see right now is you see lots of utility companies basically saying, oh, the only way we can possibly meet demand for AI is to build all this gas right now. And the problem with that is that ends up locking in all kinds of emissions, because once you've built something, you have this incentive to kind of try and get your return back on building this in the first place. And this feels like, I don't think people have realized just how much of a stick this is going to be, because as far as I can tell, all the laws from the EPA basically say, look, you can't build gas like this, and you can't actually do this. So we've got like this case of massive build out of AI coming up against all these regulatory forces as well. And it's going to be quite a significant fight in the next 6 to 12 months, I think, because we've now had our honeymoon period of all carrot, like you said in this piece, and now we're coming up to the stick, which is the other part to kind of make sure that you can make sure as a significant part of the US grid is going to be decarbonized by, I think it's the mid-2030s, basically, is what they're doing, that they're aiming for with this. But we have the same thing in the UK as well. Like the UK right now, we've got a target for, the UK has agreed to try and decarbonize the grid entirely by 2030, which is great for us as an organization, because we want a fossil-free internet by 2030.
Yeah.
By 2030. So we're like, oh, thank God the UK is doing this.
Yeah, right,
the UK government, one of the big kind of manifesto policies from Labour coming in, who've just won the election, is we're going to have a clean grid, entirely clean grid by 2030. So 5 years, basically 5 years' time, they're going to get rid of almost all the fossil gas generation, right?
How are they going to do that?
That's what we'll find out. But the thing I found out when I spoke to some people who, basically, this is actually all based on some modeling using a piece of software that we interviewed a chap called Igor Rietman, who was talking about this in one of the episodes. We'll share a link. That software was basically these kind of things were put together by some analysts on our laptop saying, well, this is what you can do. There's a report called from Ember Climate where the report is called Escape from Gas, I think, or a path out of gas. And this was one of the things that was written in 2022 when gas was super expensive, to say, well, this is one thing you could plausibly do for this. And yeah, when the thing about policy, people reach for what's there. This turned into one of the things that one of the parties led on. And now we're going to see if we do see a fossil-free grid and fossil-free internet in the UK by 2030. Because it's fascinating. This is the most excited I've been about UK politics in a very long time.
I don't know. I might dampen it for you. There's a lot of manifestos that come out from governments when they join, and there's a lot of disappointment in the years later when it doesn't manifest, when their manifesto doesn't manifest.
So this is the final thing that might be relevant. So the modeling that was used for this as the basis to say, yeah, we can do this. It's one thing that ends up being, so I'll share a post which I ended up doing a bit of research and speaking to some of the people about this. It's actually very conservative, more conservative than the National Grid's own estimates.
Oh, really? Right.
About specifically in our industry, demand side response and batteries, right? So these are the two big things that we're likely to see a massive increase in.
That's what gas is used for, more like this is specifically to get rid of gas, right?
So
it's all about peaker plants, and then therefore you can do a little demand response will...
Partly that. The thing that they said is like their plans basically are relatively conservative about the ability for demand side reduction, making your carbon aware in stuff like that, right? And there is another thing that we've seen is that the UK government is actually being quite gung-ho about deploying all these new data centers. So I'm kind of thinking, is there a chance to actually say, well, okay, if you're going to have this deployment of all these data centers, and you know that one thing you're going to need to have is a much more responsive grid, is there a path for all this kind of carbon aware infrastructure to actually serve some of the roles that you wouldn't have typically rely on peaker gas plants to actually fit. There's a bunch of stuff there, and I think we'll learn basically because this has been a really ambitious goal, and you've also got this other idea to like bring in something which can be quite flexible, but only if you incentivize infrastructure to be flexible, because for the most part we don't see an economic incentive passed down to the consumers of infrastructure to be using this right now. So maybe this is a help one piece.
I mean, I think there was some really good work done kind of several years ago, and this will be really good because one of the things I've seen is that all the positive moves that I saw kind of 3 years ago regarding new data center rollouts, hydrogen fuel cells, kind of building kind of a much more advanced data center seems to have gone back a little bit. And you're right. I think data centers could lead the way in terms of demand response. I'm not even talking about compute demand response. You can just stick batteries, you can fill data centers with batteries and then they can store and then they can do their own sucking from the grid when it's clean and powering their own infrastructure when it's dirty. There's other solutions which doesn't even necessarily need kind of a software.
Exactly.
Consumes, I
mean, this is one thing that we've seen in Ireland. There's precedent in Ireland where people have said, if you're going to be connected to the grid, you need to be prepared to be kind of complementary or sensitive to the needs of the grid for this. So I think there's actually room for this, and it would be really nice. I think that this feels like, given such an ambitious target, it does feel like a role where you could actually tell a good story about green software and be part of the solution as opposed to part of the problem. Because a lot of the discussions around like rolling out of digital infrastructure is basically saying, we can't possibly meet this demand. But if we accept that demand is dynamic, then there is a chance to actually fit this in. And that feels like definitely worth going for, particularly to kind of maintain this kind of social license for operation, particularly for technology firms.
And I think a lot of what you just said over the last kind of like couple of minutes runs very counter to what we were saying before about, I mean, everything you just described, like this is all related to that whole idea of additionality. And it's all about how do we truly transition the grid to be fossil free. And you need solutions like this, not necessarily buying unbundled RECs, but you need to actually like think through, well, how do I be a better citizen in the grid infrastructure, do demand response, be sensitive, not demand energy when everybody needs it, and therefore we have to spin up a gas power plant or something like that. So these are the kind of things you need to actually transition the grid.
Asim, I think we might have fallen down a bit of a grid rabbit hole.
Yeah, we've done it again, haven't we?
Yeah, so we're going to have to move on. I think we've come up to time. Yeah. But Asim, it's really nice to see you again. I'm glad you had a nice holiday. And I guess we've got a bunch of new things to do this quarter, right? With various projects we have inside the Green Software Foundation and in the other member organizations related to it. All right, dude, it's Friday, so have a lovely weekend. And for those listening, we'll put all the links to everything we've discussed in there. And if there's something you didn't see, please do let us know, and we'll make a point of adding it. All right, Thanks a lot, folks.
Thanks, Chris. Bye.
See you around, Asim. Bye. Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.